You walk in. The plant is running. Blowers are humming. Pumps are steady. Nothing looks on fire. No alarms are screaming. There is no overflow. There is no chaos. If someone walked in off the street and saw your plant, they would say, everything looks fine. But you don't work here to look at what's loud. You work here to see what's quiet. Because real incidents rarely begin with explosions. They begin with small weirdness. Let's slow down the room. You sit at the desk, you open yesterday's log sheet, you pull up trends, and now you watch closely. You don't see any spikes, but you find bends. You find a DO trend, short for dissolved oxygen, inside the aeration tank that curves slightly downward. You may find an ammonia value of the effluent that is still under limits, but has been rising 3 days in a row. You may find a clarifier surface that just looks different. Not bulking, not boiling, just not the same as yesterday. Or a faint odor in the headworks building that wasn't there last shift. Nothing illegal, nothing catastrophic, just signals. Now I ask you, which one would you act on first? And what is the smallest safe action you would take? Pause. Let your brain answer. There is no panic here. This is where operators are made. You learned a loop earlier. Theory to plant to river. Now we add something new. Decision to branch to outcome. Every small choice creates 2 futures. Ignore the trend or investigate. Assume it's noise or confirm to check. Wait until it fails or buy safety time. Good operators do not wait for certainty. They move to the next safest step. And here is the simple pathway you will use for the rest of your career. Notice, confirm, respond, record, and escalate. Let's slow each word down. 1. Notice. This sounds simple. It is not. Notice means you are paying attention to patterns, not just numbers. It means you remember what normal feels like. This is why trending is powerful. Not because the exam says so, but because humans detect curves better than isolated values. On the exam, they will often give you 3 days of data. They're not testing math, they're testing pattern recognition. If it's moving in the wrong direction, it matters, even if it is still within limit today. 2. Confirm. Confirm means check one more thing before you guess. Not 10 things, 1. If ammonia in wastewater is creeping up instead of reducing, check DO. If clarifier looks different, check sludge blanket depth. Confirmation reduces guessing. It prevents overreaction. This is professional restraint. 3. Respond. Respond does not mean overhaul the plant. Respond means make the smallest move that buys time. Increase aeration slightly. Resample. Check calibration. You are not solving the entire problem. You are stabilizing the system while you gather information. This is critical exam logic. When unsure, stabilize first, diagnose second. 4. Record. This is where many weak operators fail, because writing feels like paperwork. But logs are not paperwork. Logs are our collective memory of how the wastewater treatment plant has been performing over time. When you write in the logbook, ammonia trending upward, increased air slightly, will recheck in 2 hours, you are protecting the next shift. You are protecting future you. Exams can test this quietly. If a result is drifting, the correct answer often includes document and inform. Not hide, not wait, document. 5. Escalate. Escalate early, not after failure. Call before you are overwhelmed. Good operators ask for help before it becomes an emergency. Blame culture says, who caused this? Reliability culture says, what signal did we miss? You want to work in reliability culture. Case 1. the slow rise in BOD. Picture this. For 3 weeks, the BOD level in effluent wastewater comes back like this. Week 1, 18. Week 2, 22. Week 3, 27. All 3 results are still passing. All 3 are within permit limits. There are no alarms, there is no violation, and there is no panic. So everyone stays relaxed about it. But here's the trap. The river doesn't care that you're still within the limit. What matters is the direction. BOD is not just a number, it is a measurement of how much oxygen will be stolen from the river after discharge. And here's the dangerous part. A slow rise in BOD is often quiet. It doesn't scream, it drifts. Why might this drift happen? It could be simple, boring things, like aeration slightly underperforming, diffusers beginning to clog, a blower not delivering full air, increased organic load coming in from upstream businesses, sludge age shifting without anyone noticing, clarifier solids washing out slowly, sampling time missing peak loading periods. Nothing dramatic, just small changes. So what happened in this story? The plant didn't fail. Nobody broke anything. The problem was simpler. People looked at each result as a checkbox. Pass, pass, pass. They did not look at the pattern. If someone had noticed the drift at week 1, the correction would have been easy. Check DO and aeration, inspect diffusers and blower output, review influent strength trends, increase sampling frequency for a few days, observe settling quality in clarifiers. Small moves, early moves, because BOD is an oxygen debt, and small debts grow if ignored. No heroics, just attention. Case 2. TSS spike. Picture this. You walk in for day shift. Lab result shows effluent TSS is higher in wastewater than usual. It's still below the limit, but compared to yesterday, it's doubled. Yesterday, it was 8. Today, it is 16. Again, technically, the value is passing because it is within the limit, but your operator brain should go, okay, why did it double? TSS is not chemistry, it's physical solids leaving the plant. And when solids leave, something inside the system lost control. Your first check is not the permit, your first check is the separation process. Because TSS in effluent usually means one thing. Solids that should have stayed behind escaped. So you check the fastest mechanical and process signals first. How does the clarifier look? Any cloudiness near the weirs? Sludge blanket level rising too high? Return activated sludge rate, correct or drifting? Was there a recent flow surge from rain or high influent load? Is there bulking or poor settling in aeration? Then you make the smallest stabilizing move. Adjust RAS rate if needed. Reduce flow if possible during peaks. Inspect skimmers and weirs. Confirm sludge wasting rate. Pull another sample to verify. Document immediately and notify supervisor early, not as panic, but as professionalism. This is the reflex pattern you want built into you. Observe, stabilize, confirm, record, and escalate. Why it's exam gold? Because most scenario questions are not testing math. They are testing whether you ignore trends because it's still passing or think like a system operator. On scenario questions, if the answer includes wait until it violates the limit, it is usually wrong. If the answer includes verify, adjust safely, document, notify, you are likely on the right path. Let's zoom out. Decision-making under uncertainty feels uncomfortable. Your brain wants certainty before action, but plants move in time. Any delay creates accumulation of waste pollutants, but become harder to handle. You learned mass balance earlier. If waste load increases and the response is 0, waste accumulation happens. Decision delay is accumulation. Tiny delays grow. This is systems thinking applied to judgment. Here is an important rule for operators. When unsure, don't freeze. Zoom to the next safest step, not the biggest step, the safest. What this kind of thinking produces in you are not memorizing pollutants, you are building pattern recognition, controlled response, documentation discipline, and early communication habits. These are employable skills. These are promotable skills. These are licensure skills. Now, let me ask you one final question. If incidents are really about judgment under uncertainty, if small signals matter more than loud alarms, then what does a good operator actually look like? Not technically, but personally. Let's go there next.